Hi everyone. Um, can you hear me? And how's the sound quality? Okay. I see on my side sometimes I have the sign that the internet connection is kind of low. So if there will be some problems, maybe the voice will be breaking or anything else, please let me know, and then I will switch off maybe the video channel, the stream from the camera, or maybe I will do something different. Um, okay, so there was the question from Nikita. Um, okay, give me a second. I will take a look what we have there. I suppose there's the question about the homework number 3, right? Is it so? No, lesson number 5, homework number 3. Okay, I suppose yes. Okay, so what was there? Give me a second. I can tell you what was the problem. Um, okay, so there were 5 subtasks, right? Literally 5 tasks. You submit only 4. So and in one of them there was the mistake somewhere. So that's the reason. Since you submitted 4 out of 5, so it means the maximal value could be 8, right? If you have some mistakes somewhere, then it will be reduced a bit. But anyways, we can discuss it after the lesson if you like. Maybe 2 or 3 minutes we can spend for that discussion, but let's do that after the lesson. Anyways, you will have a chance to convince me that I was wrong, pulling you that mark. But it's fine. Let's do that afterwards. All right. So today we have we will be working on certain algorithms. Well, the story is pretty easy. Let me share my screen. So let's take a look on some algorithms we can use. Can you see my screen, guys? Is everything cool with the screen share? Nikita, I already answered you. And as I said, after the lesson, I'm ready to hear something from you. You can always convince me that I'm wrong, so let's do that after the lesson. Okay, so we have, well, I copied here a couple of, oh, and by the way, I put you another homework. So since you know time is moving on, so guys, you need more practice. So I pulled you another homework, lesson 8, homework 5. So it just means that that homework is based on one-dimensional arrays and solutions which have to be created. They have to be done by applying one-dimensional arrays. That's the only reason why I connect a lesson and a homework. Okay, so there are a lot of things possible to be done. Surely we have here a couple of materials placed in the Word document. Well, in our case in PDF. But anyways, guys, mostly when we work on data and we pull data into, let's suppose, arrays, actually it doesn't really matter if it's the array or it's the table, like a two-dimensional array or maybe three-dimensional array. We always do that to make and afterwards work with the data. And believe me or not, but depending on the way we pull data inside the array and principles we use to store the data, basically we affect by that then afterwards work in the matter of the time, which means, well, for example, let me give you an example. So let's suppose you have shelves of books and you're about to find out some exact author's exact tome. So it means, well, the certain author, certain tome of the book. So if only you have the chaos on your bookshelves, so it's pretty hard to find it out. So you will have to take a look on each book, on each of the books, and you will have to read the author and read which the tome is that. But if you collected all of those books, like on the one shelf, you have one author, all collections of tomes, even sorted 1, 2, 3, and so on and so on. And if you apply this method for all of the books, then it will be pretty easy for you to find out the necessary information. So the same for storing data in arrays, because data, frankly saying, data is not only the number. For example, we have here one-dimensional array, we store numbers in it, but again, it's just a number. But in the same time, it could be the text, or it could be the object, which we didn't have a talk about, but I suppose we will have. It could be a complicated object, not just value, but some structure. Okay, and if you will need to find something up in the array, you will need to spend the time, and most likely you have to think in the following ways. So you prepare the array, or you read the array of data from somewhere, and you use that at least 10 times. So you have to be thinking in a such way. Well. By my experience, I can say that in most of the cases, such arrays which are received from some data source, they're used pretty often, and in most of the cases, it's not that only 10 times per the application run. Sometimes it's 100, sometimes it's 1,000. Sometimes you have to automatically search information in such arrays, and it becomes 10,000, 100,000 times per the application run. It is the normal case. And if only the searching procedure takes a time, let's say the second, right? Let's say second. And if only you need to find information, let's say, I don't know, maybe let's say 10 times, right, in the array. Let's say you're looking for 10 elements. So just imagine user presses some button in your application, or maybe presses enter if it's the console app, and your application starts for, let's say, 10 seconds. what you would think about such application? I suppose you would say, well, what the issue is happening, right? You would say, well, maybe it's a bad software because it doesn't respond. It shows, okay, application looks like stuck. We have to finalize that. That's what most of the users would do. And you, as future developers, you have to get this. You have to understand this correctly. So is the idea clear for you why we need the sorting of data, why we need a preparation of data to be done? At least theoretically. Okay. So we have an ordered array, and let's say let's suppose we would need to find out the element. Okay, well, which will be the element? Okay, actually, it doesn't matter, but the main principle is how to sort that. Well, idea is super simple. Well, there are a lot of methods for doing that, but here we have the super simplified case. Well, we always have to be working with two elements on for each of the pair of elements, and we need to compare them. Literally, if we would need to, let's say, store data in this array in ascending order, what we would do, we would take a look on the first pair of element. If they are placed in the needed sorting way, then we are just leaving them. We take another pair and we again compare them. They are fine for now. So we take another pair, then we swap them, then we take another pair again. If they are placed correctly, it's fine. But here it would be the 8, then we would swap it, and we would just go till the end of the array. And we need to do that literally as many times as we have here elements minus 1. That would be amount of times we would need to do that for a so-called the brutal sorting case. Surely here you can find out here you can find out the code which literally finds out the greater value, the greatest element on the in the array, literally the biggest. Okay, here we have the Borland approach for the randomizer, but I suppose you remember, guys, how to deal with, let's say, Dev C++ or whatever other compiler you're using. So we're using sequence rand instead of randomizer, and instead of random we use rand, and then we divide that with the remainder. Okay, anyways, guys. This would be this would be the way how you find out element for unsorted array, and it's fine. It's totally fine. But let's imagine we have, instead of 10 elements, let's say million of elements, which is a bit more close to the real case. Well, it means we need to go through all of those elements, finding out the necessary one. Well, I would say it's kind of bad case. So what we will be using this time? So we will be using a so-called swapping algorithm. It will, the idea of the swapping algorithm is that we will have some temporary variable in which we will store a temporary the value to exchange data between two elements. So this algorithm will have to be applied. And here we have some definitions, some examples. For example, a bubble case, the bubble sorting algorithm. But before that, we will be trying to get what is the brutal method of sorting the algorithm, sorting the array, and we will find out what is the cost of each of the methods we will overlook today. So I'm switching to the Windows system. And I will be opening Dev C++ like we do that all the time. Okay, it's stuck a bit. Okay, so here it is. All right, I will have to save it somewhere. Okay, so what we can do, we can use libraries. Okay, which method of the output to use? Okay, maybe I will be using maybe iostream. No big difference. I'll be using the time or time.h. Let's see what this compiler contains, and the standard library will be used. Since I'm using iostream, I will be using namespace std by default library. So we'll be using namespace std, and I will be making the main function. Okay, and I will create the array. I will create the array of the following values. Oh, and I suppose I will need to have the size of the array. I will take the array which comes from the example, maybe from here. I will take it, and we will be using this example to find out costs of storing the data. And I will need to literally place a comma separator between the values. Okay, how many values do I have? 5 and 5. Okay, so overly it's 10. And I will place maybe here 10 value as well. Okay, that's great. Okay, we'll have to save it somewhere. Okay, I will receive the temporary file. And now let's create the code to print this array out. So I will be using the index I for this purpose. Okay. And I will be printing the value, and I will be printing a space. And afterwards, I will be given a new line symbol. So if you don't remember, handle means the new line symbol, the same as I would give here /n. So that would be the same. Okay, so let's see if that really works, but it has to work. Okay, I have to use time h and maybe stdlib h. Let's see. Yeah, looks like great. So we have this array. That's cool. That's cool. The only thing I'm started to think this array is pretty small still. Maybe I will just generate the array. Maybe it will be much better. So I will randomize it, and I will say the values will be between 0 and 9. Let's see if that will be fine. Yeah, that's great. We can even give more varieties of numbers. Let's see. Well, yeah, that's really cool. Maybe we can even use more varieties. Yeah. Now it looks really great. Okay, so we have the array of 30 elements of the unsorted array. So as you remember, we can go through the array and we literally can we literally can work with each pair of elements of the array, and we can literally compare each of the pairs if they are located in the correct order. How to do that? This method sometimes is called as the brutal sort. In the end, I will give you this file, so no worries, guys. I will place these comments exactly for you, so you could remember which method, which way we used. So what we did here? Well, we went through the array. Until the pre-last index. That's why I pulled here -1, and I will compare, guys, the current the current index value with the next one. Well, but what is the next one? Well, it's I plus 1, like the current one and the next one. So if they're located in proper way, because I would like to have cascading order. So from the smaller value till the bigger. So if on the left I have the bigger value than on the right, then I will have to change their places. What I will be using here, I will introduce here a new variable. I will call the temp, like a temporary. And I will be using that for swapping values. For example, it will be in a such way. So I assign a value from AI till well to the temp. Then I rewrite AI equal to AI plus 1. Nextly, I place the value of the temp to AI plus 1. Okay, so by that I'm open that. And we can print the array out so we can see what we get in the end. Let's see. So as you can see, what we literally did, well, we went through the array and some of the elements are swapped. So you see that. But since we do that only one time, we literally are not applying this procedure for all of the values of the array, because you see this 5 is located here, because if it was swapped, then it was swapped only once. Yes, the previously this was the position of the 5, so it was swapped only once. Well, but as you understand, to make this 5 appear in here in the place of 21, we have to do that some amount of times. So, which means that well, we can think like going through the array. We move an element of one pair in its correct position. Let's suppose like that. So this 80. No, this 98 is standing in its necessary position. So it came from where? From here, since we were moving elements from the left side to the right side, so from this position it being pulled here. So we have to do this, we have to repeat this literally as many times as we have amount of elements in the array -1. So let's fulfill our algorithm and let's see if it really works. So I will call that repetition as J. So J will be working. So one time I will be moving that. Oh, maybe I can use just the 0. Well, yes, from the 0 to the pre-last index, which means I will do that n -1 amount of times. So literally that's correctly. So, so here I have this amount of repetitions of this algorithm. Let's see if I will have my array sorted. Well, do I have it sorted? Well, yes, it's been sorted. But another question, guys, what is the price of this? And let's now calculate the price of this. For the calculation of the price, I will be introducing a variable called steps. And before the method, I will say steps will be equal to a0. And each time I make a comparison between elements, I will be increasing the amount of steps. And after I printed the array, I will even print amount of steps done. So brutal sort will be the text, steps equal, and steps. So let's see how many comparisons did I do to sort that array using the brutal method. So so we see I spent 841 comparison to do that. Well, we can judge if it's small or big number, but again, imagine that we have a huge array. Instead of 30 elements, imagine million of elements. So this amount of steps will raise will be really raised. It will be enormous number. So they should be taken into account. So, so our question would be, which methods can we use to make this to make this preparation of data happening faster? That could be the question which we are about to solve. Okay, maybe some of you would like right now to compile the stuff. So for those guys, I'm copying the code in the chat. As I told previously, I will give these full sources for you, so no worries. So are we good so far? Do we get what we done? Do we get the price of this action of the sort in the array? Is it clear for me where I took that from? Okay, great. So now, guys, I would like to take a look with you on several methods. I suppose today we have a time to overlook three methods, and I would like to take a look on you on several methods, and we will start with the bubble sort. Here we will have a couple of video examples. I'm not sure if stream is working fine, so but anyways, let's overlook the video for the bubble sort. Well, descriptions on this website related to certain algorithms really wonderful. I really like this, so that's why that's the video I would like to take a look at with you. Let's see how this bubble sort working. Okay, so so we took a look on this method, and literally, let's think about what we can do with our algorithm. How can we have a smaller price for the certain algorithm? So what I will be doing, guys, I will copy the code which I have so far. I will place it. I will place it here, and I will comment the brutal sort in a such way, so it would be still in the codes. And here we would have the bubble sort. So as you understood, guys, a difference here is that each time we go till the end of the array certain pairs of values, each next time we use for one less index of the elements we are reaching by the pair comparison. So which means, guys, here we can influence this coding as follows: minus j. So the first time j will be 0, so it's not influencing, and we are going through the all pairs of elements. Next time we are going till the pre-last element. The pre-last element of the array will be last one, which will appear in the last pair. And next time we take for one element less and less. Well, that's how that works. So let's see if that works well, and let's take a look on the price of that. So let's run it. And what we have, guys? Surely we have different numbers because we have randomizers, so all numbers will be such ones. If we will need to use the same numbers, we can do that. So we can pull some specific value at the sequence round. Maybe we need to do that. Maybe we need to do that. Oops. Just in case, we would have a comparison for a specific for a specific value. Then let's use that. Okay, so we have the array and it's being sorted. Well, the price for that is so big, so it literally approximately 2 times less than the brutal sort. But still, you see, we have the same result. So all values of the 30 elements are being sorted. So, so as you can see, the bubble sort has its own advantage, and it's more beneficial than the brutal force. Okay, I will give you this code for the bubble sort, just in case some of you is trying to do that during the class. So guys, the question for you, are we good with the bubble sort? Is bubble sort clear for us? Okay, somewhat yes. So again, I would like to encourage you guys to ask questions. If there is something not fully clear, you can always ask, and we can spend time to make it more understandable for you. Really, I'm not gonna bite you. So, guys, really, if there are questions, pull the question ahead. We will find the answer. Okay. So the bubble sort is kind of good stuff, but they are but they are kind of modifications of the bubble sort available, and one of them will be the next method we're gonna take a look at. So the next method will be so-called insertion sort. Well, some programmers call that insertion sort as the stone sorting. But again, it's just a matter of the lexicon which we're using. Okay, so Aldona didn't get about steps. So steps is the price for sorting the array. Literally, it's how many times do we compare elements. Surely, we can think like if statement takes us so small amount of times. But guys, for the brutal sort, for example, we have it as many times as we have amount of elements square, right? Uh, Somewhat it's the same for the bubble sort. Uh, uh, okay, not really. Actually, it's bigger, but for the bubble sort, it's n square. Here we have. Um, Here we have a real n square. If for the bubble sort that value was reduced, sorry, not reduced, but kind of rounded. But for the brutal sort, it's really n square. If we have millions of elements, so it will be millions times by million times. So we can imagine how big is that number, and just multiply that with the price of one if statement, comparing two numbers, and you will find the actual price for doing that. It will be quite long time anyways. For the bubble sort, it's twice less, approximately. That's the idea. Okay, let's take a look on the stone sorting, or how it's officially being called as insertion sort. It's the modification of bubble sort. Let's take a look at this. Okay, so literally, as you can see, now amount of times we would be spending on this insertion sort literally depends on elements themselves. And there is a kind of the worst case scenario and the best case scenario. The best case scenario is when the array is already sorted, so we just make as many comparisons as we have elements -1 in the array. That's the best case. And the worst case, we do that as many times as we did that for the bubble sort. So literally depends on the values inside the array. Let's take a look how that works. So I will copy this code and I will comment that. Okay, so here we'll have insertion sort, and let's make modifications of this. Okay, so what we have here? Well, literally, we are gonna to compare. We are gonna to compare elements. I will make it somewhat similar to the pseudocode which was provided there. So I'm going through. I'm going through elements, and I will be compare elements like the previous and the current one. So so the current one will be 1 and the previous will be a 0. So I will say that I have index j which will be equal to I value, and I will be making a steps back in the array from every I value when I need to make the swapping of elements. So literally, which means if I need to swap them, let's do that here. So while a j minus 1 is bigger than a j, so literally if they are standing in proper way, then I'm swapping them. How? Well, I can copy this code I have previously created, and I can just use it here. But instead of I put j, and instead of I plus 1, I put j minus 1. Like I'm working with the current element aj, and with the previous element aj minus 1. Okay. So as you remember, here I have to reduce the j value, and I have to use even another condition according to the pseudocode. We can take a look on that if you like. Yeah, so this while contains two conditions. The first is a need of swapping the values, and another one if the current value is bigger than a 0. So which means the last index of the j will be 1, because 1 is the smallest value which is bigger than a 0. So how do I do modifications here? Well, I place one condition in one brackets, and another condition will be placed in another brackets. So here we'll have j bigger than a 0. And literally that will be the whole magic of this method. As you can see, nothing super complicated, but let's see let's see for this exact array, what will be the price, what will be amount of comparisons. So we have to calculate them somehow. Well, as you understand, here, each time we reach this while condition, we are making a comparison, right? So Let's examine also steps before well, and and in the end of the iteration of the problem person, and depending on that, we run an iteration or we're not running that at all. So let's do it in a such way. And now let's run for this algorithm. Let's see if that works and what is the result. So what we have. Okay, looks like we have a problem here, so I didn't do something. Let me take a look. Ah, yes, here I placed -1, which is incorrectly. Sorry for that. Yes, now it's correctly. So we still have the same array because for the randomizer I used a certain value. So each time I run the code, I will have the same randomized values, the same each time. And you see, for this exact array, I have such many comparisons did for this method. So you see, it's even less than for the bubble sort. But again, there could be the best case scenario and worst case scenario. So I'm somewhat more to the worst case scenario here, because this method could cost even less than this value. But if we would have another values in the array, in the initial array. That's the idea. That's the whole magic of this insertion sort. Okay, so I will copy you these codes if you will need that. So the question for you guys: are we good with insertion sort? Is it clear for us? So what would you say? Okay, that's awesome. All right, so let's maybe take a look on some other things. Okay, here I have a such thing as the shell sort, core sort, and others. Well, let's take a look on the shell sort. That will be another interesting thing. Oh, okay, it's the site for the YouTube. Okay, let's take a look what we have there. Okay, an ad. Okay, let's finalize that. Let's wait until the end of that. Okay, a second ad. Okay. So guys, This method, as you can see, was invented uh, literally decades ago. So we can count. Okay, now we have literally some 60 years ago, approximately, right? So you can take a look, and this method is still used in the programming, like laws of physics, laws of mathematics. Here nothing has been changed since those times. So let's take a look for the next minutes of this video. Okay, so I suppose the idea is kind of clear about how this sorting is happening. Surely we have seen the code in the Java. Well, I suppose idea could be clear behind that. The shell sort itself um, it's kind of really interesting um, to be implemented in C++ language. The only thing we have to work on indexes correctly, because when we are going through elements, we have to be really accurate with indexing system. That's the only thing. Um, so let's maybe take a look on that code again. Let's see what we have here. Okay, so firstly we get a size of the array. Well, here we have the Java language, but by the len we receive the size of the array. In this case, we find out the biggest um, um, the biggest step we can use between elements by the third x plus 1 rule. Nextly, what we do, we go back from the biggest value of that to the smallest value of that, and we literally go through elements of the array, and what we do, well, we're swapping elements actually. If it's found out that there are elements which are placed in the incorrect order. So how can we try to use it? Well, we can firstly replace this a.len with some value, with 30 in our case, and we can just try to implement this. Well, it will be actually the regular rewriting, but only here for the last, we have to say that aj is less than aj minus h. And here we will have the swapping algorithm. Well, since we have a bit of time, let's try to implement this. And what I will be doing, I will be maybe pulling this on the left side of the screen, and I will be pulling my Windows system here on the right side, because oh boy, um, because I'm about literally to make the rewriting of the code. I could do that, how to say, in my way, writing that shell method, but I will give you the one which comes from the theory. Okay, so we have to introduce h, which will be equal to 1. Then we will be increasing it till the following case. So h will become 3 multiplied with h plus 1. So literally it's the principle of 3x plus 1 rule. Okay, that will be the one thing. The next thing. So we have another while. So while we're in the range between the biggest value, which is created by this code, and 1, which is the smallest case, then we are producing these changes. So we can literally rewrite this stuff. Okay. So we are going through elements from h till n minus 1. Those are indexes. And again, we are working on these indexes, but as you understand, we can extend these parts of the for loop condition. And okay, so we have this one. and in the same time, AJ, literally AJ minus H is bigger than AJ. So literally the previous element is bigger than the current one. Yes, that will be the reason for swapping. And we decreasing J by H. Yes, like this. And here we implement the swapping algorithm. That includes these two indexes. Well, the story is super easy. So we write AG minus H to temporary variable. So we can rewrite AG minus H to AJ value, and let's write value of the temporary variable into AJ. So that will be the method. And now what we can do, we can make the printout. So we will have the shell sort. Let's even name it here in the comment, shell sort. The only thing we need to give steps. We need to give some operations. Well, the first operation will be finding out the biggest value. So we can say that here we make an increment of the steps. And then what we have? We have increase here because here we have a comparison, and in the end of each iteration we will have comparison as well. Like for the previous case, when in the end of the iteration we need to make another comparison to find out if we need to run another iteration. So same as here. Okay, well, I really hope I wrote everything correctly here. Let's try to run it, and let's see if we will get the results. Okay, it might happen I made a mistake somewhere. It could happen. Okay, maybe I will place this condition into specific brackets, because this thing can be understood by compiler in a different manner. Okay, maybe I will make some CLs to get where do I have the problem. Okay, will I reach to the download of the star? Yes, I have. Okay. Okay, then I will print out a value of I. Find out how fast I'm going through these things. Okay, looks like somewhere I influenced the I value. Okay, let's see. Here I is equal to H. Okay, let's find out the H value. What is it? So H equal, then let's have this H. I have to take out that printout, yes. Okay, let's see. 13. So things are fine. Yeah, so 13. So literally there will be three cases, one for 13. Okay, that makes sense. All right, so I have to find out how it happens that the I value becomes a 0. Oh, okay. What I forgot here, I forgot to make an influence of age. Yes, yes, that's the reason. That's the reason. Okay, let's see if we have the result. Well, yes, guys. So we have the results. So here we have the sorted array, and you can see that we have the following cost of we have the following amount of comparisons, literal operations we're using within this method. Well, there are even another methods available for sure, um, but you see that it's possible to work on them. It's possible to choose the method which is more understandable, more clear for us. Implementation. And as it was already said in the video, this method is the most correct one. Literally one of fastest methods. Surely there are another methods like the quick sort, which I really like. So the quick sort is super quickly can be created. Here, maybe you can take a look on that video afterwards after the class. There is the folk group which implemented the dance in the way of the sorting. So if you will like to take a look on that, you can take a look maybe after the class. I really hope you will like that. And if you will like, maybe next time we can program sort, maybe selection sort and the merge sort as well. But let's see. Okay, anyways, I will give you these codes, so no worries, guys. I will upload this into Moodle. We have a couple of minutes, as I see, left for the class. So maybe it's time for Q&As. So is the shell sort clear for you? Maybe some of its aspects are not really clear because this method anyways uses totally different technique. So we have a selection of the steps between elements we're using. Okay, so for Laurinus, it's clear. That's awesome, great. What others would say? Is the method clear for you? Maybe we have to discuss some of its parts. Okay, makes sense. Makes sense. Great. Okay. So, do we have any questions about what we took a look today at? Okay, looks like no questions. So next time we will continue this topic because we have to take a look on another methods and we have to implement with you the method for looking for the element in the array. So to find out what will be the next step, how it became beneficial for us, such sorting of arrays. So, but anyways, that will be for the next time. Okay, so thanks guys for being connected today. I really appreciate this. I really like to see that almost everyone is here. Please still be working on your home tasks. And I suppose at this time, at this moment, we can finalize the class, so I will be switching on recording, and I will ask maybe one of our student, Nikita, to stay in the session, and maybe we can discuss a bit about his homework. And to the rest of you, thanks again, and see you next time. Bye bye, guys. And Nikita, please stay in the session.
Да, я